All right, good afternoon. My name is Tibor Kremic. I work at the NASA Glenn Research Center, and I'm going to talk to you today a few minutes about a unique place in our solar system. It's famous for being hot. Someone want to guess what planet we're going to be talking about? Anybody know your planets? Venus. Okay, that's right. We're going to be talking about Venus. So, from a science perspective, what are some of the reasons why we might be interested in exploring and learning more about Venus? Well, Venus, in many people's eyes, is kind of like a twin to Earth. So in our little picture here, we've got twins. One of them can represent Earth and the other represent Venus. They're basically the same size as many twins are. They're basically the same mass. They're made up of the same materials, we believe. They're close to each other in the solar system. But while Earth is very nice to us in terms of our ability to live here, Venus is anything but that. So what are some of the things about Venus that is different, but it also makes it very interesting and a science exploration goal for us? So if you don't know, the temperatures on the surface of Venus approach about 900 degrees Fahrenheit. So if I had a chunk of lead in my hand, very quickly on Venus it would turn into a puddle. The pressures on Venus are about over 90 times that of the pressures here on Earth's surface. So imagine if you're a diver, and some of you probably are, it'd be like diving about 1 kilometer down underneath the ocean surface. So quite a bit of pressure. And if that wasn't enough, there's a number of other mysteries about Venus. Venus, by far, is the slowest rotating planet in our solar system. In fact, its day is longer than its year. In addition, while you see it slowly spinning around, you'll notice that it's spinning backwards from the other bodies in our solar system. So all these questions, beg the other question of why. Why are all these things different about Venus and it's so close to us here? So while we have Venus that's slowly rotating, doesn't have an inclination, there's no seasons, everything's very, very uniform, but we do find that if we go up into the clouds, that the winds on Venus are whipping around the planet at tornado-like speeds. And this goes on year after year after year. So what is it about Venus where you have very little temperature differences, there's no seasons, but you've got the super rotation phenomena where the winds whip around the planet? That's another mystery that we want to understand. Venus is also covered in a very thick layer of clouds, about 20 kilometers worth of layers of clouds. And these clouds prevent us observing the planet easily, but they're also composed of primarily sulfuric acid. So 70 to 95% of those clouds are sulfuric acid. So if you're a spacecraft that wants to go down to the surface of Venus and explore, you're going to get a refreshing shower of sulfuric acid on your way there. Another mystery about Venus is really its interior. We know very, very little about it. We know that there's no magnetic field. So obviously there's something different inside than we know about right now. So these are just some of the mysteries. I can tell you more about why Venus is interesting and why we, as a planet right next door, would want to learn more about it. What might it tell us about our own planet? So it's similar, but so different. So why not just go there and figure out all these things, right? We've sent some missions to Venus before, some orbiters, and the Soviet Union has sent some landers. So why don't we have answers to many of these puzzling and important questions? Well, Venus, these extreme environments and its unique situation makes it very challenging to do exploration. For example, from a remote sensing, an orbiter that you put around the planet, you can peer at the clouds, but there's very little ability to actually go through and penetrate down to the surface and understand that. We've done radar missions and we have coarse topography information, but very little beyond that. And then if you think about going down here, the difficulty there is that you don't have anything that actually works very well or lasts very long. The missions that have been sent to Venus so far have not lasted longer than 2 hours. So it's difficult to do time kinds of science over that period of time. So you have extreme temperatures that kill your systems. You've got a dense CO2 atmosphere that makes it very difficult to peer down. Power, we don't have very much sunlight. It's very difficult to get power on the surface of Venus, so that makes it very difficult to do really much of anything. So these are challenges. But of course, we work for NASA here, and we love challenges, and so we're tackling these problems. And so what are we doing about these? NASA is investing in developing high-temperature systems. So these are different kinds of electronics, there are different kinds of materials that can actually function at temperatures around 500 degrees Celsius. So high temperature electronics, high temperature sensors, batteries, these come from various sources like aeronautics, engine research, different type of combustion systems. So there's heritage in some of these things, and we're actually showing these can work for thousands of hours. NASA's also built simulation capabilities. So in the center where I work at the Glenn Research Center, we have a Venus simulation capability where we can reproduce the pressure, the temperature, and the precise chemistry anywhere in that atmosphere. And we can do some experiments, which is the other thing that we're doing. We're understanding what actually are the physics that happen there, what to look for if we were actually going to go, and then what might that data look like, and how do we interpret it? If we see something, and the temperature and the environment affects those signals, what are we actually seeing and what are we learning? So these are some of the things that NASA's doing. We're also looking at concepts and building prototypes for future exploration. So again, at the center that I work, the Glenn Center, we're building prototypes that are using some of these high temperature systems to be able to survive on the surface, not for 2 hours, but for 2 months or more. So if there's a way for me to get the mouse, that's my amazing video for you all. So we are developing these, and this is in work, so in the next few years we'll have these developed, and we'll actually test them in the Venus environment that I talked to you about earlier. There are developments. This is a balloon that the JPL folks have been developing. So this would allow us to explore more of that cloud layer in somewhat more benign temperatures. We don't have to go quite down deep and get so hot. And then, of course, there are lander concepts that are in work. We can imagine doing seismometry and more advanced exploration. So Venus is a really interesting place. We want to learn more about it. It's certainly a challenging, but we're up to that challenge, and we're looking forward to going back there. Thank you.